Shake Table Lab by Ethan Park and Spencer Scott. Construction 1. First, we started building the first floor without any base. Construction 2. Then, we added cross braces to the first floor to keep the floor strong. Construction 3. Next, we fixed up the top of the first story. Construction 4. Then, we started to work on the second floor. Construction 5. The last thing we did was to add the cross braces to the second floor. Project dimensions. The height of the second story was 20.5 centimeters and the height of the first story was 20 centimeters. The dimension of the second story was 19.5 centimeters square and the dimension of the first story was 16 centimeters square. Testing. For testing our structure, we started out by placing one sandbag on the first story and one sandbag on the second story. Then, we shook it on the shake table, and it did not break. That means that we have to add one more sandbag to each story, and it also did not move or break. So that shows us a good sign that we would do pretty well on our final testing. Strengthening. We put a lot of tape on our structure to make it very sturdy. Strongest part. The strongest part of our tower is the ceiling of the first story because of the strong multiple cross braces. Weakest part. The weakest part of our tower was probably the bottom of our structure because there is no base to support the structure. String. The string was used to add to the perimeter of the tower so that the sandbags wouldn't fall off the sides during the shake table testing. Tape. The area where the most tape was used was at the bottom of our structure because we had no base. Extra supplies. If we had 5 extra straws, we would put a lot of extra support near the bottom to help the structure not fall apart, since there is no base.
This is the light one.
Oh, it's starting to... It's only on the
problem.
Spencer's
All right,
like,
so now we're
This is 11. Sensor readings. We put a sensor on top of our structure. The sensor picked up the movement of the structure. The green, which is the x-axis, is the movement back and forth, depending on how the sensor is rotating. The orange, which is the y-axis, is the movement up and down. And the blue, which is the z-axis, is the movement forward and backward.
Hello, my name is Ethan Park, and I am reporting ESPN Sports Center News.
How many sandbags did your building support?
Our building supported 10 sandbags.
Where did your building fall?
Our building fell at the bottom right corner and the centerpiece that supports the building.
If you were going to build it over, what would you change?
I would add more support to the center so that the building wouldn't collapse that easily.
What did you learn about building strong earthquake-proof buildings?
I learned that cross pieces are very important to keep buildings stable.
What did you like about the building project?
I liked that it was kind of a challenge and it was very fun.
How many sandbags did your building support?
Our building supported 9 sandbags.
Where did your building fail?
Our building failed on the middle center piece and on the bottom right corner.
If you were going to build it over, what would you change?
I would add more supports that went from corner to corner instead of right to left.
What did you learn about building strong earthquake-proof buildings?
That they need a lot of supports and it's not easy to make one.
What did you like about this building project?
It was a lot of fun to work with my partner Ethan Park and trying to find ways that will support the sandbags the most.
Thank you.